Hello everyone, I am Raksha, Assistant Professor of Mathematics from Canara Engineering College. In this video, let us learn one of the important topic of mathematics that has a wide range of application in science and technology. However, it is also a part of our course, that is Module 3, Fourier and Z transforms. As the name itself suggests that this is the transformation introduced by a French mathematician Jean-Baptiste Joseph Fourier while studying the heat equation in metal plates. As you are already familiar with Fourier series, Fourier transform is an extension of it. One of the major difference between Fourier series and Fourier transform is related to the type of the signal it considers. In the case of Fourier series, only those periodic signals that satisfies the Dirichlet condition can be expressed as a linear combination of sine or cosine waves. Whereas in the case of Fourier transforms, even the non-periodic signals can also be expressed as an integral of sine and cos. Let us learn how to find the Fourier transform of a function. Fourier transform, also called as a complex Fourier transform of a function f of x, is defined as f of x is equal to integration of f of x into e to the power isx dx, where the integral is varying from minus infinity to infinity. Capital F over here indicates the Fourier transform acting on the function f of x. Just make a note of it. What is the meaning of transform, students? Transform is nothing but a change, isn't it? In the case of a Fourier transform, a function of time domain f of x is transformed into a function of frequency domain f of s. So changing a function from time domain to a frequency domain is nothing but an Fourier transform. Inverse Fourier transform is a reverse of it, and it is defined as f inverse of f of s is equal to 1 by 2 pi integration of f of s into e to the power minus isx ds, where the limits of the integration are from minus infinity to infinity. Where your capital F of s over here indicates the Fourier transform acting on the function f of x. In order to solve the problems on Fourier transform, it is necessary that you should know the formulas of both Fourier transform as well as inverse Fourier transform. So just make a note of it. There are some results or properties that are necessary to solve the problems on Fourier transform. First property, linearity. For any two functions f of x and g of x with any two constants a and b, the Fourier transform of the function a into f of x plus b into g of x can be written as a into the Fourier transform acting on the function f of x plus b into the Fourier transform acting on g of x. The second result, the function f of x, that means a function of time domain, is said to be a self-reciprocal with respect to the Fourier transform if the Fourier transform of the function is directly proportional to the given function at x is equal to s. The third result is a well-known result, nothing to do with the Fourier transform, but however very useful to solve the problems on Fourier transform, that is e to the power ix can be expressed as cos x plus I sin x, and e to the power minus ix can be written as cos x minus I sin x. combining these two results, you can easily follow cos x and sin x. Hoping that you have understood the results on Fourier transform and the concept on Fourier transform, let me get into the problems. Here is the first problem. Find the Fourier transform of the function f of x is equal to e to the power minus a into mod x, where your a is positive. From the definition, the Fourier transform of the function f of x is defined as integration of f of x into e to the power isx dx, where your x is varying from minus infinity to infinity. What is your function f of x over here? F of x is e to the power minus a into mod x, right? Just substitute it. So the above integral reduces to the form integration minus infinity to infinity e to the power minus a into mod x into e to the power isx dx. But what do you know about modulus function, students? Mod x is defined as minus x for all x less than 0 and it is equal to x for all x greater than or equal to 0. What is the meaning of it? If I just consider this as a real axis, in the interval minus infinity to 0, the modulus function takes the value as minus x, and in the interval 0 to infinity, mod x takes the value x. So I am going to split the integral minus infinity to infinity as the sum of the integral varying from minus infinity to 0 and 0 to infinity. So the above integral changes to the form integration minus infinity to 0. What is your modulus function in the region minus infinity to 0? It is minus x. So replace your mod x by minus x. So minus into minus, it is plus. So you are having just e to the power ax into e to the power isx dx, and in the plus integration 0 to infinity, and in the interval 0 to infinity, modulus function is defined as x itself, isn't it? So the integrand is of the form e to the power minus ax into e to the power isx dx. I can rewrite this integral as integration minus infinity to 0 e to the power a plus isx dx plus integration e to the power minus of a minus isx dx, where your x is varying from 0 to infinity. Since you are evaluating, since the integration is with respect to x, a plus is will be acting as a constant. So the integration of the e to the power a plus isx is e to the power a plus isx divided by a plus is, where your x is varying from minus infinity to 0, and in the second case it is e to the power minus of a minus isx divided by minus of a minus is, where your x is varying from 0 to infinity. Just apply the limit, students. When you are applying the upper limit, as your x is equal to 0, e to the power 0 is 1, so it is 1 by a plus is. As your x approaches to minus infinity, e to the power minus infinity is 0. Okay, plus into minus, that is minus. As your x tending to infinity, e to the power some constant minus some constant into x tends to 0. So the first value is 0 over here, minus the lower limit. When you substitute x is equal to 0, it is e to the power 0, so that it is 1 by a minus is. Just simplify it, students. You are going to get the answer as 2a by a square plus s square. So what is the Fourier transform of the given function? The Fourier transform of the given function is 2a by a square plus s square. Hope you got it. Next problem. Find the Fourier transform of the function f of x is equal to 1 for mod x less than or equal to 1, 0 for mod x greater than 1, and hence evaluate the integration sin x by x as x varying from 0 to infinity. Just make a note of it, students. In this problem, they are expecting you to find two things. The first thing is, they have asked you to find the Fourier transform of the given function f of x, and using the Fourier transform, they told you to evaluate the integral sin x by x. So let me first concentrate on Fourier transform and then go for the integral part. From the definition of the Fourier transform, f of x is given by integration f of x into e to the power isx dx, where your x is varying from minus infinity to infinity. Let me first analyze the function f of x over here. F of x is given as 1 for mod x less than or equal to 1. What is the meaning of mod x less than or equal to 1? For all mod x less than or equal to 1 implies your x is varying from minus 1 to 1. However, the given function f of x is defined on the whole real line, but in the interval minus 1 to 1, the function takes the value 1. Outside this interval, the function value is 0. So, evaluating the function or finding the Fourier transform in the interval minus infinity to infinity is same as finding the Fourier transform in the interval minus 1 to 1, because outside this interval the function value is 0. So the above equation or the above integral reduces to the form integration minus 1 to 1. What is your function value in the interval minus 1 to 1? It is 1, right? So it is 1 into e to the power isx dx. Evaluate this integral, apply the limits so that you are going to get it as e to the power is minus e to the power minus is by I into s. However, I have given it in the result. This is nothing but 2 sin s by s for all s not equal to 0. So the first part of the question is done over here. That is, the Fourier transform of the function is given by 2 sin s by s, but however this is true for all s not equal to 0. But if I want to see where does the Fourier transform of the function approaches in the close neighborhood of 0, the Fourier transform approaches to 2. And here is the description for it. F of 0, you can calculate the value of the Fourier transform of the function at s is equal to 0 using the limit, that is limit s tending to 0, the Fourier transform of the function, that is 2 sin s by s. As s tending to 0, sin s by s tends to 1, so the function value is 2. So the Fourier transform of the function in the closed neighborhood of s is equal to 0 is 2. Now let me just evaluate the value of this integral using the Fourier transform. But however, in order to find the value of this integral, I have to use the inverse Fourier transform. Now by using inverse Fourier transform, let us evaluate the integral sin x by x as x varying from 0 to infinity. From the definition of the inverse Fourier transform, f inverse of f of s is given by 1 by 2 pi integration of f of s into e to the power minus isx ds, where your s is varying from minus infinity to infinity. Just make a note of it, students. The integration is with respect to s, not with respect to x. So your x will be acting as a constant over here. From the previous slide, the Fourier transform of the function is given by f of s is equal to 2 sin s by s. Just substituting it in the given integral, 1 by 2 pi integration minus infinity to infinity 2 sin s by s into e to the power minus isx ds. Just cancelling the terms 2 over here, the equation reduces to the form 1 by pi integration minus infinity to infinity sin s by s into e to the power minus isx ds. Just observe the integrand of the inverse Fourier transform and the integrand of the required result. In order to get the integrand of the desired result, this exponential term should be eliminated, and I can easily eliminate this exponential term by substituting a particular values for x. So by substituting x is equal to 0, e to the power 0 will be equal to 1, so that the integrand of the inverse Fourier transform and that of the desired result coincides. So substituting x is equal to 0, the above equation reduces to the form f of 0 is equal to 1 by pi integration minus infinity to infinity sin s by s ds. But what do you know about the function sin s by s, students, in the interval minus infinity to infinity? It is actually an even function. And if you don't know how to check the function is even or odd, here is the description. Just go through it. Okay. Since the function is even and you are evaluating in the region minus infinity to infinity, so it is same as evaluating the function in the interval 2 times 0 to infinity. So the integral reduces to the form 2 by pi integration 0 to infinity sin s by s ds. What is the function value at x is equal to 0? The function value at x is equal to 0 is 1, because the function is defined as 1 for all those values of x lying in the closed interval minus 1 to 1, and 0 is a point which lies in the closed interval minus 1 comma 1. So what will be the function value then? The function value will be equal to 1. Just rearranging the terms over here, so that the integration of sin s by s as s varying from 0 to infinity will be equal to pi by 2. So the value of the integral sin x by x as x varying from 0 to infinity is pi by 2. Hope you got it. Last problem, students. Find the Fourier transform of the function f of x is equal to 1 minus x square for mod x less than or equal to 1, 0 for mod x greater than 1, and hence they have asked you to evaluate the integral x cos x minus sin x by x cube into cos of x by 2 as your x varying from 0 to infinity. Let me first concentrate on the Fourier transform and then evaluate the integral. From the definition of the Fourier transform, f of x is given by integration minus infinity to infinity f of x into e to the power isx dx. But what do you know about the function f of x, students? F of x as defined as 1 minus x square for mod x less than or equal to 1, which means in the interval minus 1 to 1, the function value is 1 minus x square. Outside this interval, the function value is 0. So evaluating the Fourier transform in the interval minus infinity to infinity is same as evaluating the function in the interval minus 1 to 1, because outside this interval the function value is 0. So the above equation reduces to the form integration minus 1 to 1, 1 minus x square into e to the power isx dx. Now using the Bernoulli's rule, by choosing the first function as the algebraic function and evaluating the integral, I get the first function into the integration of the second function, that is e to the power isx by is, where your x is varying from minus 1 to 1. So just put alternate positive and negative signs. So the second term is negative minus into the differentiation of the first function, that is 1 minus x square, which is nothing but minus 2x, into the integration of the second function, so that it is e to the power isx by is whole square, where your x is varying from minus 1 to 1, plus the derivative of minus 2x. What is the derivative of minus 2x? It is minus 2 into integration of the second function, that is e to the power isx by is whole cube, where your x is varying from minus 1 to 1. Just apply the limits and simplify it. Since you are having x square in the first term, so the whole term reduces to 0. And when I am applying the limits for the second term over here, it is minus into minus plus, but you are having I square in the denominator, which is nothing but minus 1. So it is minus 2 by s square e to the power is plus e to the power minus is. And in the third case, it is minus 2 divided by I cube. What is your I cube, students? I cube is minus I. So it is minus 2 by minus I, that is nothing but 2 by I s cube into e to the power is minus e to the power minus is. Apply the result so that the equation reduces to the form minus 2 by s square e to the power is plus e to the power minus is, that is nothing but 2 cos s plus 2 by I into s cube e power is minus e power minus is, which is nothing but 2I sin s. I have already mentioned these things in the slides, in the previous slides. Just go through it. Just on simplification, the Fourier transform of the function f of x reduces to the form minus 4 into s cos s minus sin s by s cube for all s not equal to 0. But if I want to see the Fourier transform of the function in the closed neighborhood of s is equal to 0, the Fourier transform approaches to the point 4 by 3. And here is the description of it. The Fourier transform of the function at s is equal to 0 is given by minus 4 into limit s tending to 0 s cos s minus sin s by s cube, which is a 0 by 0 form. So applying L'Hospital's rule and simplifying, the limit reduces to the point 4 by 3. So the Fourier transform of the function is 4 by 3 in the closed neighborhood of s is equal to 0. So that completes the first part of the question. Now analyzing the second part of the question, students, that is, they have asked you to find the integral value of x cos x minus sin x by x cube into cos of x by 2. So using inverse Fourier transform for it, from the definition of the inverse Fourier transform, f inverse of f of s is given by 1 by 2 pi integration of f of s into e to the power minus isx ds, where your s is varying from minus infinity to infinity. Just substituting the Fourier transform of the function, so the integration reduces to the form 1 by 2 pi integration minus infinity to infinity minus 4 into s cos s minus sin s by s cube into e to the power minus isx ds. Just cancelling the terms over here, minus 4 by 2, which is nothing but minus 2 by pi into integration of minus infinity to infinity s cos s minus sin s by s cube into e to the power minus isx ds. Just observe the integrand of the inverse Fourier transform and that of the desired result over here. Instead of the exponential function, you need the term cos of s by 2 or cos of x by 2, right? And this term I can easily get by substituting a particular values of x, because the integration is with respect to s. So your x will be acting as a constant, right? In order to get cos of s by 2, I am going to substitute the value of x to be 1 by 2. So that the above integral changes to the form, the left hand side of the equation will be f of 1 by 2, that is equal to minus 2 by pi integration of s cos s minus sin s by s cube into e to the power minus is by 2, where your s is varying from minus infinity to infinity. But what do you know about e to the power minus I theta, students? It is cos theta minus I sin theta, isn't it? Let me use that result. At the same time, what do you know about the function? The function f of x is defined as 1 minus x square in the interval minus 1 comma 1, and half is a point which lies in the closed interval minus 1 comma 1, right? So using these two results, the equation reduces to the form 3 by 4 is equal to minus 2 by pi integration minus infinity to infinity s cos s minus sin s by s cube into cos of s by 2 minus I sin s by 2. Now just taking the real part of the above equation, students, so that the equation is of the form 3 by 4 is equal to minus 2 by pi integration s cos s minus sin s by s cube into cos of s by 2, where your s is varying from minus infinity to infinity. Now just observe the integrand of the inverse Fourier transform and that of the desired result. They are coinciding, isn't it? But observe the limits over here. You need the limits from 0 to infinity, right? But over in the case of inverse Fourier transform, you are having it from minus infinity to infinity. And you can easily reduce it to 0 to infinity just by observing the function to be an even function. And I have left you to check it. So evaluating the even function in the interval minus infinity to infinity is same as evaluating it in the interval 2 times 0 to infinity. Just rearranging the terms so that the value of the integral s cos s minus sin s by s cube into cos of s by 2 with s varying from 0 to infinity is minus 3 pi by 16. So what is the value of this integral, students, then? The value of this integral is minus 3 pi by 16. That completes the problem. Here are the set of 3 problems which I gave it as an exercise. Just try to solve it so that you can understand the concept in a better way. Thank you.